Hello, everyone. My name is Melanie Kimchiwango, and my research is bees on campus. Let's start with a little introduction. There's around 4,000 species of bees that live in the United States and Canada. Bees are common in most areas around the world. However, many of us don't recognize more than half of its species. I have a picture down below, and I want you to take a look at it and see if you can identify which ones are bees and which ones are not. And the answers are right there if you want to check. Let's see how many you get right. Now, the main difference that a bee is and has is their very little hair, and that they have a little big belly versus wasps who barely have any hair and their skin skinny waisted. There's always exceptions though, and we'll learn more about that. There are 7 bee families. We have the Andrenidae, Collectidae, Melitidae, Halictide, Megillid, Apid, and Stenotridae. We'll start with Andrenidae. And the Andrenidae family is one of the largest family of all bees. They are found everywhere around the world except for Australia. The 2 largest genus in this family are the Andrena and the Perdita. Andrenidae are sometimes known as mining bees because their nest is close to the ground and some nest below the ground. A fun fact is that the bees in this family are smaller than mosquito. Some of the species in them, they're smaller than mosquito. Callidae. This family contains varying species, many of which are generalists and specialists to many wildflowers. And they carry pollen internally, unlike other ones that carry in their legs or abdomen. Melitidae. This family is not common in North America. There's only around 33 bee species in North America, and they're non-existent in Australia and South America. Usually they're found around southern parts of Africa. Collectidae is a family known to be found in every continent. In the United States alone, there are over 3,500 species. Their social behavior depends on the climate they're inhabiting. So one species at a low elevation can be social and be colonial, while at a low elevation, the same type of species can also be solitary. Megachilidae, the family of the beautifully colored bees. These bees can have a tint of purple, blue, or even copper. The name means big-lipped family, so their mouth parts are huge. You can see a picture right over there. Apid. This is the most recognized of bees because the family of these bees are the honeybees, the bumblebees, the carpenter bees. So usually Apid is very recognized. Some of the species in this family are the Ceratina from the Apid family. They are parthenogenic, which means they don't need any males to reproduce. The Stenotridae family is known for their very large hairy bodies, but they're exclusively found in Australia, so you won't see many of them here. Research question. So what's our question? What's our research? We wanted to see how many species of bees do we have on campus? And to do so, we needed some traps. We got the pan traps, the Lubing traps, and the sweeping method traps. We did an location of transit areas to test it on campus. We did around 5 of them, and some more in other areas. But the ones that we did the most were by the Life Science building, by the College Science of Humanity. We did one by the across the Austin Hall, and another one by the Old Main Memorial, and by the Whitehall dorms as well. So the pan traps, these are plastic traps and they're arranged in a yellow, white, and blue pattern. So you paint them and then you arrange these patterns, and they wanted to resemble like a flower. And you put a little bit of soapy water and that should do the trick. You have to put the traps early in the morning and collect them late in the afternoon. And how you collect them is through a strainer, and then you put them in a bag with alcohol solution in them. Lubing traps is a little similar to the pan traps, You add a little bit of water and soap, but you hand these in trees instead of putting them down on the ground. You collect them as well in the afternoon, the same way that you collect the pan traps. The sweeping method is a little bit scary for me, but if a bee is caught, grab the net, tightly clench where the opening is for the bee to not escape, and then quickly tip over the net, like pinch it, and then the bee will start crawling up. Insert the bee with the net in an insect killing jar with a little bit of ethyl solution, then close the jar. Wait for the bee to stop moving, open the jar, and take it out of the net. Then collect it in the jar. Later on, you can start pinning them. So after the pan traps and the Lubing traps, you need to process these bees because they can't stay in the alcohol solution. There are 3 steps into processing bees. The first step is to remove bees from the alcohol solution container or bag by dumping them into a mason jar. And you'll see the pictures right there. You have to have a net lid so they don't escape while you're doing the shampooing process. With a little bit of soapy water, you let the water run until all soap is gone. And the final step is to dry them. You just need a hair dryer and the mason jar with the net, and you start drying them just like that picture right there. And how do you know they're dry? Well, they'll start flying around. So you'll see them start flying. You'll think, oh my God, are they alive? They came back? But no, that's whenever you know that they're dry. But make sure to use heat-resistant gloves because the mason jar can get hot whenever you're doing this process. Now, pinning bees. Once the bees are dry, begin pinning them by using the following. You need a microscope, pinning needles, styrofoam board, and a pinning block. And sometimes you'll need some pinning forceps because they can be very small. Looking through the microscope, hold the bee with its thorax facing out on top of the styrofoam board with your thumb and index finger. With your other hand, grab a pin needle and push it through. Make sure that the bee's thorax is parallel to the styrofoam board. Using the pinning block, adjust the correct height the bee needs to be for labeling purposes. Now, identifying bees and collecting data. Using the microscope and with the help of discoverylife.org or an expert, identify the bees collected, create an Excel spreadsheet, and begin classifying the bees by family, genus, species, sex, number of specimen, location, and date collected. I know you guys are excited. These are the results. We have found 22 species found on campus so far, which is crazy, but it's awesome. We have, honeybees, we got some osmias, we got some blueberry bees, we have some bumblebees, and we have some sweat bees, and I have every single picture of them so you can take a look at it, glance through it. Let me see. Right here, we have some osmias. They have a little tint to it. Remember, I was mentioning mega killers. They have kind of like a tint to it. They're beautifully colored, and you can see better in the microscope when you take a look at it. Now, why are bees important? These are important pollinators, especially those from the aphid family, like the honeybees and the bumblebees. They're economically crucial to us. And in the book, "And the Bees from Your Backyard" from Wilson and Carroll, they talk about the honeybee as a machine responsible for nearly the entire almond crop of North America, not to mention countless other fruits and vegetables. So they're pretty important to us. And even some of the other species, they're important for wildflowers. They pollinate a lot of them. So why are some species of bees declining? Some species of bees are declining because we continue to grow exponentially, and a lot of our approaches are not sustainable. As a result, many of our rural areas have become more urbanized, some to an extreme that you don't see vegetation. I have a picture right there, and you can barely see any green. And so many species that live underground or inches above the ground are threatened by urbanization because their nests are paved and their habitats are destroyed. So how can we help? The first step to help bees is to learn more about them, their behavior, their habitat, through research just like this one. By identifying the species of bees we have on campus, we can better their habitat by providing them with nests and food sources they like to forage for. This on its own can help species thrive in urban areas, like the Sam Houston State University. I'll also take a minute to thank Dr. Pescarella for the guidance and the time he has provided me through this research. And thank Ms. Ava Fujimoto Strait, who has helped me throughout this process of the poster. And finally, I would like to thank Sam Houston State University for allowing me to conduct this ongoing research until last year before the pandemic. Thank you so much for listening to me today, and I hope you have a nice day.